On this question, we want to construct a polynomial function that might have the given graph. So we're given this graph of a polynomial function, and we want to take a look at our zeros, our x-intercepts, because the zeros tell us what the factors of our polynomial will be. So because we have a 0 of -4, that means that our polynomial will have a factor of x plus 4. Here we have a 0 of -2. However, this particular 0 is touching the x-axis, and that means that it has a multiplicity of 2. So I know that instead of having just one factor of x plus 2, it's going to have two factors of x plus 2. And it might not have two factors, but we do know that it's going to have an even number of factors. So because the graph touches at that 0, we're going to have an even number of factors instead of an odd number of factors. This x-intercept that we did a moment ago crosses the x-axis, so it will have an odd multiplicity, and that's why I said it has one factor. It could be any odd power, but we're just choosing the lowest to keep our polynomial simple. We have one more 0 here. We have a 0 of 2, and our graph crosses at that point, so we're going to have an odd factor of x minus 2. So we'll keep that to the first power because the multiplicity will be odd for that 0. So when I'm forming my polynomial function, it could have the coefficient of a, which we don't know. We do know it's going to have a factor of x plus 4, a factor of x plus 2, and we're going to say it has an even number of factors because that 0 has an even multiplicity. And then we have a factor of x minus 2. Now, one other piece of information that we could glean from this is the sign of our leading coefficient. And we can figure that out based on the end behavior. So looking at the end behavior of our graph, we have both of our ends going in the same direction, and that matches with the degree that we've come up with here. So we have 2, 1, and 1, so it's a 4th degree polynomial. The ends are going in the same direction, and these ends are going both up to positive infinity. So that means that our leading coefficient will be positive. If our end behavior was going down to negative infinity, then our leading coefficient would be negative. Now I pulled this question, and the question had some multiple choice options. So I'm going to put those multiple choice options up here so that we can take a look at and see which one makes sense. So here we have a factor of x plus 4, a factor of x plus 2 squared, a factor of x minus 2, and a positive leading coefficient. So that's a possibility. So I'm going to put a question mark there as a maybe. In this next one, we have a factor of x plus 4, x plus 2, x minus 2. And this one we're going to have to rule out because this only has 3 x's, that would be x to the third power, and the n behavior wouldn't match that. In an odd power, the n's go in opposite directions. In this next one, we have x plus 4, x plus 2 squared, x minus 1, that would work. However, the leading coefficient is negative, so we know that the n behavior would be going to negative infinity, so let's rule that one out. The next one has x plus 4, x plus 2, but only one power of x plus 2, or one factor of it, so we know that doesn't match the multiplicity at that point. The next one has x plus 4, x plus 2, x minus 2. The multiplicity doesn't match, and also the degree doesn't match. That's an odd degree, and the n behavior doesn't match for an odd degree. Then we have x plus 4, x plus 2, x minus 2, but our multiplicity doesn't match on these two, so we can rule that one out. And we have only left with one option for this particular polynomial function. That's f of x equals 1/16 times x plus 4 times x plus 2 squared times x minus 2. Thank you for checking out my videos. Have a great day.